Greetings and salutations. Welcome to question 3 of the 2019 organic examination. This is the last question and this looks like a short one, so let's get started straight away. So this is question 3. So first question, they circled function groups. So this just comes down to knowing what the function groups they are. So the A is an OH group. OH group is an alcohol, and B is an amine, and C is a carboxylic acid, because that's the basics of function groups. And if you really struggle with level 2 organic, I have some bad news for you. Level 3 organic contains level 2 organic chemistry, so you do need to, and I always stress the importance of organic chemistry to my level 2s. I always say if you want to do level 3 chemistry, organic is the last paper you want to SNA, because if you're going to SNA organic in level 2, you are not going to do well in level 3. I mean, it's all related. I mean, all 3 externals in the level 2 are linked to level 3. 2.6 is probably the least linked, but 2.6 is probably the easiest, because a third of its rates reaction, which you learn in level 1. But anyhow, that's not related to this particular question. Okay, so we got given these things. We got given red litmus paper, bromine water, blue litmus paper, and acidified dichromate solution. So you need to understand, guys, that amine are basic. Okay, so when you see NH2, this is alkaline, this is a base. When you see COOH, the name has it is a carboxylic acid, so this is acidic. So straight away, when you have litmus paper that you can use, you're going to use red litmus paper for amine, because those will turn blue. And when you have carboxylic acid, you're going to use the blue litmus, and this will turn red. Okay, now how do we use alcohol? So we're done with the litmus paper. Now litmus paper only distinguishes acid and bases. Alcohol is neutral, so we can choose between bromine water and the acidified dichromate. Just remember, bromine water, let's just expand out of here. Bromine water is only useful for alkanes and alkenes. You don't use it for anything else in year 12 and level 3 chemistry. So if you see Br2, alkenes and alkanes only. Okay, but so in this case we're going to use the acidified dichromate, and again redox, this is orange and this will go to green. The other really popular one we covered in in question 2 is permanganate. This goes from purple to colorless. This one's a little bit easier to remember, because I always just tell people, remember, God, I can't spell tonight. Just remember that the alliteration, purple potassium permanganate. Okay, so and it goes colorless. Yeah, why does that look like it? Yeah, I'm very bad with spelling tonight. Colorless. Okay, all right. Let's move on to the next part. Next part, describe an alternative method to distinguish between B and C. Identify the reagents needed, expected observation, and explain the type of reaction. No. So this is kind of linking to level 1 chemistry, level 1 acids and bases, because amine is a base, carboxylic acid is an acid. So how did you distinguish acids and bases from from level 1? They said we want to use a reagent, the exact observation, explain the type of reaction. Now, when they say those things, they wouldn't accept universal indicator. Okay, because universal indicator, if you put universal indicator into the acid, it's not really doing anything. You're adding it is doing anything. It is doing something, but that's not covered in the level 2 syllabus. That's not a reaction you would have learned. Okay, so we're really asking you in this question to do either these 2 reactions. You either do acid plus metal, or you can talk about acid plus carbonate. Because if you have acid plus carbonate, you will make salt and hydrogen gas. And how are we going to see hydrogen gas? Bubbles. So that's how we can know which one is the acid. If we make acid plus carbonate, you will make salt, water, and H2O and CO2. How do we know this reaction is occurring? Because you make CO2 gas, which is bubbles. Okay, so you can either react anything with a carbonate. So you react. So you can react B and C with, let's think of a carbonate like calcium carbonate, for example, any carbonate. The one that fizzes and make gas, that is going to be the carboxylic acid. So C will fizz and make, because what type of reaction is this? Because CO2 production, I'm abbreviating because you have the answers underneath, because this is a neutralization reaction, because you're making water. Okay, and the other one is B is a base, it doesn't react. Okay, or you can react with the metal, but the chemistry isn't great. I mean, if you put vinegar with yeah, it does react, but it doesn't react that well. Normally it does really well, reacts really well with strong acids, but this is theoretical chemistry, so we'll let you go with either one. So if you talk about again, so any carbonate, so this is sodium carbonate, you can use any carbonate, you don't have to use sodium carbonate, any carbonate, and then it fizzes because it's a carboxylic acid, neutralization reaction, you make CO2. Or, and then B is amine, therefore wouldn't react. Or you react B and C with magnesium metal or aluminum metal, zinc metal. It is an acid metal reaction because you will make hydrogen gas if you had an acid, no reaction if you have the base. Okay, so this is a distinguishing test. Next one, another kind of like a flow chart-ish kind of question. So let's scroll down a little bit so we can see the whole thing. Yes, this is the whole thing. So use this information to complete the reaction scheme below by drawing the structural formula of each organic molecule and name the intermediate alcohol and the reagents required. Okay, so we have bromoethane, and chloroethane. So let's draw that first. Bromoethane, ethane is 2 carbons, and Br there, so that's CH2, CH3, and we make chloroethane, which is CH3, CH2, and then you have the Cl here. So I just replace a Br with Cl. So what is the thing in the middle? You can do let's just go with the one that I can think of straight away. If you react this guy, if you have the OH group as an intermediate, this will be the easiest way because you only have one. Well, it's probably the only way in this case because you're restricted to one reaction. So I'm substituting the Br with an OH, and then I'm substituting OH with a Cl. So how do we do this? The reagent number 1 obviously need to have OH, so this is where you use KOH-AQ. This is substitution, and for this one you can either pick any of the following 3. You can use SOCl2, PCl3, or PCl5. Just pick one, okay? If you're at all 3, we'll just let you go, because if you do the slash, that means one or the other. Just interesting fact about KOH. If just remember, KOH-AQ is for substitution. And if you get given KOH alcohol, this is looking at elimination. So this is going from a haloalkane to an alkene. And how do you remember them? Just remember, if you look at the 2 different things, one is water, one's dissolved in aqueous solution, one is dissolved in alcohol. If you get dissolved in alcohol, then you tend to be drunk. If you're drunk, you lose stuff. If you lose stuff, you eliminate things. That's how I tell my guys to remember anyway. Or if you prefer to go aqueous, if you drink a lot of water, you tend to go to the bathroom because the water you drank is going to replace your body fluid. You replace the body fluid in your system, so that's substitution. So one way or the other, that's how you're going to remember it. Okay, now let's elaborate on the reaction scheme. For the reaction, you should identify any conditions needed for each step of the conversion and the type of reaction occurring for each step of the conversion. So both reactions are substitution, that's for sure, because the first one, you replace a Br with the OH. The next one, you replace the OH with the Cl. So you just reuse different ingredients. So this is like a really easy excellence question if you ask me. So it's both reactions substitution. In the first step, you use KOH aqueous to OH to be substituted, and then use either one of these to substitute the OH for chlorine. Okay, very short exam, very short question 3. So hopefully you found this particular exam straightforward, and you learned something, and good luck with your exams. And if you again want to share the links, send the links to your friends who might benefit from watching the recordings, and also if you want to support the channel, subscribe, leave a like, and even if you can start making comments, like leave comments in what you want to be covered next, because I'll definitely be doing 2.4 for the 2019 exams. But once I've done that particular set of examinations, what I really want to do, instead of going through all the exams, because you can find the answers online, what I can do is I can just do the important concepts. Like say for 2.4, I can do Lewis diagrams. I can do no, we already done 2.4. We're going to do 2.6 next. Sorry. So, but for 2.4, we're going to do Lewis diagrams, polarity, and like say for structure and bond, for 2.5 we can talk about major minor products a little bit more. For 2.6 we can do acids and bases pH calculation, we can do Le Chatelier's principle. So there's a lot of small, like really important facts that contribute to the excellence criteria. I mean, I'm happy to do those, and I'll just give you tons of examples in the recording. Then we can just go through those separately rather than doing exams. So you can let me know how you think about that. Otherwise, I'll definitely finish the 2019 2.6 exams, and we'll see how that goes. Okay. Otherwise, study hard, take care, and I'll see you guys around. Bye bye.